Part 1 of Lesson 6, Chapter 2 is on nonlinear inequalities. First of all, the word nonlinear means that we're going to be dealing with curved graphs, whether it be a quadratic, a U-shaped parabola graph, or maybe a cubic disco guy. It's not going to be straight lines that we're working with. It's going to have graphs that have curves. And then inequalities means that we have greater than or less than symbols that we're working with. So before we get into nonlinear inequalities, I want to talk about a nonlinear equation. Okay, this one simply says to solve x plus 3 times x minus 1 equals 0. Well, this is a U-shaped parabola graph that would cross the x-axis at -3 and +1. And so those are 4 units apart. The vertex would be someplace down here at -1 comma something, and I could find out that vertex by plugging the -1 in, and that would give me 2 times -2, which would be -4. So the vertex would be at -1, -4, and the graph would look like this. And the solutions to this problem are just the x-intercepts. -3 and +1. Pretty simple problem. So now if we take that same graph but apply an inequality to it, if we have to solve x plus 3, x minus 1 less than or equal to 0, again it's going to have two x-intercepts. It's going to have one at -3 and +1. Its vertex would be at -1, -4, and the graph would look like this. But since it's an inequality, less than or equal to, okay, we have to consider all the values that are below or on the x-axis. So all these points here that I'm shading, that's the solution. So I like to give this answer in an interval notation. So we'd say -3 to +1, and we'd put brackets on both of those. And the reason we're putting brackets on both of those is because our inequality symbol right here has an equal to part, which means we consider those points on the x-axis. Sometimes you'll be given problems of this nature, but it won't be in a factored form. So the first thing you'd want to do is to factor it. And then after you factor it, you want to draw a sketch. This one's going to cross at -1 and +3. Okay, and its vertex would be at 1, -4, and it's going to open up kind of like this. But then you have to pay attention to this inequality symbol. Now this inequality symbol is a greater than or equal to, so therefore the solutions are all the points that are above or on the x-axis. So we got two separate regions that have points above or on the x-axis. So we'd have to answer this with an interval, -infinity until you get to that x-intercept at -1, and then unioned with 3 to infinity. That's the two regions that I shaded on the graph. Sometimes you won't be given a U-shaped parabola curve. Sometimes you'll be given a cubic. So you want to first get it in a factored form. So I'm going to need to move all terms to one side. And then I start doing my factoring. And it looks like it factors into x plus 2, x plus 1, and also has an x. So I've got 3 x-intercepts. I've got an x-intercept at -2, at -1, and 0. And since I know this will be a disco guy Randy, the graph would start down here, pass through each of these x-intercepts, and finish up there. And now I got to pay attention to this symbol right here, less than or equal to. All the points that are less than or equal to are all these, and all those points. Those are the points that are below the x-axis. So I'm going to have to say the answer is -infinity to that first x-intercept at -2 I'm using a bracket because this has an equal to part on the inequality, unioned with -1 to 0. Those are all the points that are below the x-axis for this particular inequality. Last thing I want to talk about is finding domains inside square roots. Now, got to remember that with square roots, we don't want to get negatives inside square roots. So on this first example in the top left, we simply need to take the expression x minus 6, set it equal to 0 and solve, and we get x equals 6. Anything equal to 6 or greater than 6 will produce a positive inside this square root. That's why our answer is 6 to infinity. Sometimes, though, they give you an expression like this one on the top right, where when you set it equal to 0, you get your answer. But on this one, your answer is going to be from -infinity to 3. What's the difference between these two problems? Well, you can see on the top left, it's x minus a number. But on the top right, it's a number minus x. So when you got a negative sign in front of that x, think about this, you guys. On the top right one, if I put a 4 into that, right up here, if I put a 4 into this, it'd be 3 minus 4, which is -1, and we can't take the square root of -1. So sometimes your answers are from the number like 6 to infinity, and sometimes your answers are from -infinity to the number like this one, -infinity to 3. Now the last two towards the bottom are quadratics inside of square roots. So the first thing you'd want to do is get it factored. To find the two important points. Now if you think about a graphical approach to this, very much related to the graphing problems we did earlier, it's going to cross at -4 and -2. So the graph would look something kind of like this. And so we can't have y values or outputs that are below the x-axis like these. Those are no good. So the answers that we want to give are the ones that are above the x-axis like those and these. That's why our answer is -infinity to -4 unioned with -2 to infinity. Okay, so a similar example over here on the bottom right. First thing you'd want to do is factor it. And then if you think about a graphical approach to this, you're going to have a U-shaped parabola curve that crosses at -5 and +5. The graph would open up. And we do not want to have outputs like these that are below the x-axis. We only want to have outputs that are above the x-axis like these. That's why our solution is -infinity to -5, unioned with 5 to infinity. So that's part 1 of lesson 6, chapter 2, and the homework problems you're going to be working on are 1 through 15 odd. Got to draw sketches on these. Most of them should be U-shaped parabola curves. Draw a sketch. You got to draw a sketch on those and then give me an answer in interval notation. And then 31 through 35 odd is like those last domain problems we just talked about.